Thank you very much for having me. And to small disclaimer, my Hebrew accent is very French, so people answer to me in French when I speak in Hebrew, which is terrifying. Can we please lower the light? Okay, we're gonna try something different. So we're gonna do a little exercise where I'm gonna ask you to close your eyes, but do not fall asleep. This is important. Okay, so close your eyes, and I'm going to ask you to think about autonomous technologies. Think about autonomous technologies. What is an autonomous technology? Okay, now open your eyes. Is this an autonomous technology? Autonomous cars, have you seen one here before? Did you see one driving the 101 maybe from Google or from others? Maybe. So this is an autonomous device, but we already have them today. So this is not so new technology, it's already here. And now, one of the key challenge is, how do I cross the road, not the 101, as a pedestrian, how do I cross the road in front of an autonomous car? So right now, if I see a car, I look right and I look left, and probably I'm gonna start to check whether the driver is slowing down. I don't want to be run over, that's a key element here. And I'm going to decide, probably after making eye contact, whether I should be crossing the road or not. Does this scenario make sense to you? Okay, and we're all still alive, so we've probably all crossed the road properly so far. But how do I make eye contact with an autonomous car? We don't, and it's hard. And now, if we go beyond cars and beyond today's technology, and if we think about it, we all dream about flying. And this is what I call the game of drones. And if we think about how drones are helping us today, we have drones that are helping us, for example, here, flying in a room, even. So we have very small drones. We have drones helping journalists. We have drones helping or going over people. We have drones taking photos and videos, maybe delivering parcels, maybe even crashing into the door, because I don't think this one is going to open the door. But now, if we see those little drones, they look very simple. But how do I interact with it? Can I cross in front of it? What can I do? Okay, so let's maybe lower it down and go back to the talk. And now let's imagine this person here on the screen who's walking in a park and sees a drone. What can they do with it? And so one of the issues with not knowing what to do with drone is this one. So here you have this lady who's playing golf. This is a very normal scenario. She's not very good at it, but it happens. And she gets really upset and she takes it on the drone. And this is not a joke. This is really problematic. And this is what I call unwanted or unwilling interaction. To this day, we decide to go and interact with technology. I pick up my phone. I go to drive my car. I go to the ATM. I am in control. But tomorrow, we're getting autonomous devices in our world, in our life, and they're in control too. So what happens when technology comes to just talk to us? What if I do not want to talk to this technology? What if I am unwilling to interact? And you have tons of videos, especially in the US, of people getting a shotgun in their garden to just shoot down a drone because they're worried of what happened. And it was probably just someone who could not control the drone back home. It was probably a very simple thing happening. But it is scary if we don't know what it can do. It's very much like a black box, and we don't know who's controlling it. Is it autonomous? Is it someone? Is it a positive interaction? Is it a negative interaction? Is it filming me? We don't know. It's totally opaque. And so what we're doing in my research lab is trying to understand, how do we make these technologies less opaque? How do I create suitable interactions so that people can make sense of machines that are going to live and cohabit with us in the future? And so here we did what is called an elicitation study. So this is a method to learn what would be a natural way for somebody to interact with a drone. And actually, when we did this work, we were the very first one to define the term of natural human-drone interaction. So here, as an example, we have this person, and she has to do an action which is stopped by me, and she has to get the drone from the start state to the end state. So the start is the drone is coming towards you, like we saw here, and the end is the drone is stopped, and she moves her hand and she says stop. So now I'm going to show you a video from the study that we did. That was actually a study at Stanford a few years back, and I want you to pay attention to two things: what people say and the gestures that they use. Are you ready? Are you ready? Your eyes should be open for that. Okay, let's go.
Stop. Stop. Drone, stop. Hey, boy. Here. Come here.
Drone, can you take a picture of that palm tree, please?
So this is one of my favorite. Did you notice something at the end? Please. I never say please to my computer. Never. Maybe it's just me being rude, but seriously, we are not very polite with technology. Why would people who've never interacted with a drone before decide to be polite to this drone? What is it about? And so there's many findings in this work, but one of them is, for example, here, we have very clear gestures on how to interact with drones. So for example, for the drone to come closer, people would use a beckoning gesture. And for the drone to go further away, it would be a pushing away gesture. Another fun one was a selfie where people would do this. This is not a gesture that we do in everyday life. We don't walk around like this. Well, I don't. But this is a very unusual gesture. And as gesture designers, like if I'm coding a system, an AI system with my machine learning, I am not going to do this type of gesture. And what happened here is people took from what they knew of a user interface on a phone where they needed to frame that selfie. And they took from this knowledge and they put that into gesture. What is amazing about this one is that now DJI took this whole set of gestures. DJI is one of the main manufacturers for drones today, and they embedded these very gestures into the current drones. So the research that we did got into products, into market. It is now being used. This is not now a normal gesture. It is a great way to create new technology based on what people would want, what is natural to people. And the idea is, so far, we've been forced to adapt to technology. We have to learn how to use it. We have to adapt. Why not design technology from the beginning to adapt to people? And so here, some of our main findings were that most participants throughout the course of the study communicated with a drone like if it was a person or a pet. And this is not how we know how to build technologies. We are at the very beginning of a new way of interacting with technologies by thinking about it as an animate object, as a person, as a pet. The other finding, which is major, and this is something we keep finding, people are more worried about the drone safety than their own. This is super problematic because people put themselves in danger for the technology that belongs to them. And again, you have lots of videos online of people who jump into water to save their drone. We're talking of a $200 drones and people putting themselves at risk without even thinking because it seems obvious to them that they need to save it. Probably because it's an animate object. So again, how do we reshape the technology so that people understand what is normal to do? It's not a person, it's not a pet that they're saving. It's a piece of technology that they can buy a new one. We're not even talking about, thousands of dollars machine that they have to work with. People got very, very close to the drone. Most participants got the drone within 1.5 foot of their face. This is dangerous, let me tell you. This is very dangerous when we're doing a user study. You really hope that no participant is going to get injured because the university will shut down your lab. So this is something you're very aware of. Maybe in Israel it's easier. Exactly, so as long as we do good research. But this is really worrying again because people feel safe and the technology is not safe yet. So it is really important that as we build AI systems, that these systems appear as safe as they are. It's okay if they're not safe as long as we understand that they're not safe. We need to have a correct matching between people's expectation and what is actually happening. The other thing we found is people wanted feedback. They wanted to see eyes on the drone. They were saying, where is the drone looking? What is going on? Can it have lights? Can it have sound? Can it talk back to me? And this is something that we've kept working on for the past few years. I won't have time to go on all and every single project here, but for example, we built a system where the drone could have emotions, and in that system we had the drone reacting very much like a pet would do. So it would get excited when it wanted to do something, it would look tired when it was out of battery, and we realized that people are totally able to make sense of that. It works, and that was also featured in National Geographic. Now I'm going to show you a different vision, which is a vision of how do we build a user interface for a drone. So we know how to operate a phone and a computer based on traditional graphical user interfaces. How do I create this type of interfaces for a drone? Because I can't touch it. I can't just use my touchscreen that I'm used to. So we started building scenarios. So here you have the scenario of a tour guide where you can take a drone with you. You can rent it maybe for the day or for the hour to show you different sites, bring you to a place, take pictures from afar. I took Paris because it's very emotional and I liked it. But now from a technical point of view, we wanted to build an interface that would be easy to learn, easy to use, easy to learn, unmediated, impromptu, short-term, multiple user with input and output, and to work when people would be close to the drone. It looks super easy. Let me tell you, it is not. But it was a lot of fun to build a system that would really make it easy for someone to just meet a drone and interact with it. And so this is the first system that was ever built. If I ask you how do we interact with a drone and you tell me a phone, I'm going to say no, because it has to be unmediated. The reason for that is if we think about scenarios such as search and rescue, for example, the person may not have a phone. Maybe it broke down, or maybe it's off of battery by the time the drone gets to that person. So we wanted an interface that would be solely on the drone. And so we use gestures, and I'm going to show you some examples of how we design the interface, trying to think about how a person could use a hand or feet to interact with a projected interface from a drone. And I'm going to show you now a concept video. So concept video is a great tool because it is a tool that enables us to envision the future. So what you're seeing here is not yet developed at this stage, but it is something that helps us reflect on the future we're trying to build. And so here, in this example, the lady has her own personal drone that she's walking with. So it's very simple gestures. She can interact with the menu. So here she chooses to go and see her friend. And what's really neat is she can just follow the drone. She doesn't need to look at the GPS. She doesn't need to check her phone. She doesn't need to carry anything. She can just walk with the drone, which is really simple. When she gets to her friend, we're thinking about this multi-user experience. They can play together. And if you think about augmented reality today, you have to pair two headsets. It's really complex and disconnects us from each other. But here the drone can enable them to play together. We also thought about privacy. So here, for example, the person is looking at their hand. And so they can interact just on the hand, so not everybody can see what they're doing. We're looking again here at different projection spaces, so how the person can maybe tap on the wall. And here now she goes and runs with the drone. And what's really nice here is that the drone can go at the speed that she went yesterday, at the one of her friend who cannot make it to the run. It embodies a person. It is beyond what we know about wearables today and all the health and behavior change devices. We can do health and behavior change with robots. And we've seen some of it today, but this is going beyond with something that can fly with us and is not constrained by the limits of the ground. And so once we had this vision of what we wanted to achieve, we just had to build the technology to make it happen. So we started with the needs of the users. We then built the technology to make it happen. And part of what we know how to do is to evaluate whether the technology that we built actually makes sense. And we did that with user studies. This is a very important part of the research. You can build the best technology in the world. If people are not capable of using it, it is worthless. And I'm sure a lot of you have experienced technology over time that just doesn't work, that is complex for people, that they have to learn. This is not how it's going to work in the future. So how do we create something really simple and make sure that people can use it. So here I did all the computing processing on an iPod Touch, which was very exciting. It's about 80 grams. So for people who worked in technology, you would have needed a room some years ago to do that. And now on 80 grams of technology on a drone, you can process everything in real time, all the machine learning, all the AI system. It's beautiful. The other thing is a laser pico projector, so it's always in focus. And then we use a depth camera for the sensing. So here, this is what the algorithm looks like, where it detects the head and the hand and the palm and the movement of the hand. And now I can show you some example of the interface. So the drone shows the interface. And here you see a person using it. The drone is flying above him. There is a little bit of jitter, but it's totally usable. So we managed to actually build that interface that you saw. And from that, we actually created a tour guide that was for the Stanford campus, where people can just follow the drone, get information about the building, read about it, move with it, and then with very simple gesture, tell it to stop and interact with the menu. And that was the end of my postdoc just before I moved to Israel, and I was really, really excited with the work that we did. So now let me show you about the work we are currently doing. So now we're moving on to search and rescue and interaction during the daytime. You have to realize the previous interaction I showed you, which was only in a darker environment, was the first ever interaction between a person and a drone totally embedded on the drone with no learning. That's it. We were the first one to ever build a system. So it wasn't perfect, it doesn't work in the daytime, but it was the first concept and the first technology to ever allow that. So that was a great progress in terms of research. Now for search and rescue, drones are wonderful. They're already being used because they can go to places that people can't go, that animals can't go, that robots can't go, traditional ground robots. But one of the questions is, if I'm a person and I'm on the ground injured, how do I interact with this machine coming at me? Because right now the machines are already being used, but what happens to the people who get confronted to these machines? And so those are videos, concept videos again, from the Judean desert. And now we're thinking about this drone coming to gather information from a person they're meeting on the way. At this point, we don't know that drones can gather information. So how does the drone approach the person? And part of our research was to understand in what direction should the drone approach, at what speed, at what angle, what height, what type of interface, and what happens when people are not willing to respond to the drone. Could the drone realize that the person is getting freaked out and maybe move a bit back? And those are like, each one of those questions is a research project with a different student, and it's a ton of work, but it's really amazing what we're looking at right now. Here you're seeing a person who's injured, who's hearing the drone, who's very willing to interact because she does need help. And again, we're trying to understand how can we show her what is happening, whether the drone is being piloted by someone or whether it is autonomous. How can we hand over a parcel, for example, with a water bottle to this person while they're on the ground from the drone? And now we're looking at how the drone could stop to gather information from that person before they head back to the rescue team. If you think about it, we could deploy swarms of drones to go to different people after an incident, after an earthquake, get information from people on the ground, bring the drones back to the rescue team that can do the triage based on the information that they gathered in real time from people. Right now, we're entirely relying on sensors to do this type of work. Sensors do not give you the pain level of a person. They do not give you everything. And they do not give people on the ground any information to what is going to happen to them and whether help is coming. The other question is, how do I know when the drone approaches me that this drone is here to help? And so we're looking at this concept of perception, where the drone comes towards me and I have a sense of what is this drone, what does it want, how can it help me? And so here we built a data set with all the drones that were on the market last year. So we took every single drone, we searched in every languages we could think about, and then we went and we built this data set. To this day, it is the only data set available. And as you can see on the pictures, they look very different from one another. There's different colors, there's different shape, there's different looks. And what we find is that people are able to make sense of those drones. By looking at them, they decide this drone looks friendly. This drone looks intelligent. This one, I'm more likely to interact with it. And if you see on the picture, the ones that look more like animals, people find them most likely to interact with and more friendly. And so we can actually tailor the technology that we build to what people are going to understand about the technology. So we actually built a model of perception. It's a mathematical model that helps us predict how are people going to understand the drone based on its physical features. And I'm just going to show you one example because there are many and it's very, very rich piece of research. But here, for example, when the drone looked more like a machine, it would get a score of 0. When it would look more like an animal, it would get a score of 100. So on the first column, this intercept shows you that most of the drones looked more like machines. So in average, they got a score of 30. But now, if we add eyes or a mouse or a curvy shape, or if it is colorful, people are more likely to think about it like an animal. So it's almost like a recipe book of how do we build and how do we design technology. And so, for example, if I'm a small business and I want to have my small delivery drone, I probably want it to be trustworthy because it's probably going to handle money or goods, and likable because it's representing my business. So I want it to look friendly probably and likable. So in order to do this, this is what we need. Facial features, curvy, it needs to be colorful without propeller guards, and this is what it looks like. So now we have the delivery drone of the future. So we go back to our pigeons delivering information to people. And you know, this is a very old metaphor of using pigeons to bring information or things from one place to another. But this is kind of beautiful that we can use those old metaphors to create super clever new technology that can support people, you know, in 2020 and beyond. Now, another problem in what we found here is that there is a mismatch between the safety and perceived trust. So for example, and this is very much what I told you earlier, when a drone is made to be safer, so we're going to add propeller guards that make it safer so people don't get injured, it has the opposite result, the opposite effect, that people think about it as less friendly, less likable, less likely to interact with, and less trustworthy. It should be the opposite, but this is not how it's perceived by people. So again, it's not just about building the best technology, it's about making sure that when we build top technology, that it fits to people's mental model and expectations. And so we have a lot of findings into what this looks like, you know, how friendly the drones are, intelligent, and this is really important when we build future technology, that they look like what they're actually doing. If a drone is friendly, it's better it looks friendly. If it's not friendly, it's better it doesn't look friendly. And it's important for us to know, and this is really to bring back more transparency into the technology and what it can do. So if a drone is recording or filming, you should be able to understand what is happening and maybe say no. Right now, if somebody's filming me and I'm not okay with it, I can go to talk to them and ask them to stop. We should be able to do that with future autonomous technologies around us. Another thing that I've been doing lately, and I'm actually super proud of this work, but we don't have a paper yet because it's very early stage, is I'm trying to build a cultural model of understanding of drones. So how do people understand drones and are willing to use drones in the future for diverse applications based on their own culture, practices, and awareness of the technology? So I started running a first workshop in Namibia a year ago, and then I ran one in Australia, Korea, Germany, UK, and US recently. And we're seeing major differences in how people understand the technology, how they want to use it, what are the implications for them. In developing nations where they don't have infrastructures, drones are saviors. They're literally saviors. You have a lot of places, for example, in Africa, where as soon as it rains, the roads are inaccessible for 3 weeks. So people can't even get medication. Helicopters are extremely expensive. So they don't get a helicopter to bring medication to the hospitals. They're stuck. A drone is really, really cheap. And so with a very cheap drone, we're able to just bring medication to different places, but it needs to be done in a way that is safe and acceptable. And for example, in those tribes, they were telling us that the colors matter. Because for them, some colors are associated to some tribes and some others. So in terms of ownership, in terms of who it belongs to, even the colors are important. So even within the building of the technology, the design matters. So what we're doing here is we're trying to first understand what is the right way of designing to support people. then how do we build the technology to make the technology happen and then evaluate that it actually works? We have one more workshop planned in South America, and after that we have all continents covered, and then we're going through the data right now, and it's a ton of work, but I'm really excited about it. I believe this is just the beginning. We're doing work on drones. My lab is called the Magic Lab. It's bigger than drone. We're looking at human-robot interaction, but very much how will people interact naturally with technologies in the future. For example, we're building a suit that could feel how you're doing, that could look at your emotion, that you could look at your physiological signals and adapt its behavior to you. So your clothes could become interactive. And so in general in the lab, we're very much looking at how do we create natural interaction between technology and people. I think drones are especially important because they fly, because they represent something nobody has looked at so far. And it's very much our dream to come and see the world from a different angle. So I hope you enjoyed the talk, and that's it for me. Thank you very much.